The insulin was warm by the second morning. Not hot, not ruined, just wrong. That particular wrong where you pick something up and it should be cold and it isn't, and your hand knows before your brain does. I set it back down and stood in the kitchen for a moment, the refrigerator door open, the warm air coming out of it, and I thought, this is actually the problem now. Not the power, not the grid. Ice. That's what I need. That's the thing between the medicine working and the medicine not working. I had water. I had containers. I had no idea what I was doing. What follows is not a guide written by someone who had this figured out. It's what I learned by failing, in order, through 5 days of trying to freeze water with nothing I didn't already own, and one thing I discovered on the 4th night that genuinely changed how I think about cold. The first thing I tried was the obvious thing. I filled a metal pot with water and put it outside. It was 61 degrees out. I sat on the porch and waited. Nothing happened. Obviously nothing happened. You need the air temperature below freezing for that to work, and I knew that going in, and I tried it anyway. Because sometimes you just have to touch the hot stove yourself before you believe it. Fine, that was day 1. Let's move on. The second thing I tried was the first thing that actually worked. Inside every instant cold pack in every first aid kit in the bathroom cabinet in the country, there are 2 compartments, outer pouch of water, inner pouch of white crystals. When you snap the pack and shake it, those crystals, ammonium nitrate, the same compound used in fertilizer, dissolve into the water, and that dissolution is endothermic. That means it pulls heat, not from you, from everything around it. The slurry inside that pack can reach 15 degrees Fahrenheit. That's 17 degrees below freezing. I found 5 cold packs, snapped them all, poured the slurry into the biggest insulated container I had, which was a camping cooler. I sealed a small glass jar of water, wrapped it in plastic, and buried it in the slurry. I packed the cooler tight. I waited 45 minutes. The jar came out with ice crystals forming along the inside wall. Not solid, not a block, but real ice, nucleating on glass in the middle of a 60-degree morning with no electricity. And I sat there staring at it longer than I should have, because it was the first thing that had worked, and I hadn't expected it to feel like that. The limitation is supply. 5 cold packs got me enough ice to chill the insulin case for a few hours. That's not nothing. That's actually significant, but it's a one-time deal unless you have more packs or can get more ammonium nitrate, which, before everything went wrong, was available as plain white fertilizer crystals from any garden or farm supply. 2 parts crystals to 1 part water by weight, in an insulated container. The ratio matters. The insulation matters more. Heat leaking back in from the container walls is the enemy of every chemical cooling method, and the better you insulate, the longer and deeper your cold lasts. Wrap it in a sleeping bag, stuff newspapers around it. The chemistry is doing the work. Your job is to keep the environment honest. If you can't find cold packs and can't source ammonium nitrate, there are weaker versions of this same principle. Potassium nitrate, sold as stump remover, sold as a meat curing salt, 2 words on the label in a bag in someone's garage, dissolves endothermically too. Slower, less dramatic, gets you to about 25 degrees of cooling rather than 15, enough to form a slush, enough to extend food life significantly. Urea works similarly. It's in some de-icing products. Look at the ingredient list, not the brand name, the ingredient list. Those 3 letters, UREA. Same method, same insulated container, same patience.
Day 3 was the Zephyr pot. 2 clay pots, which I got by going into a garden that wasn't mine and taking 2 terracotta flower pots that were sitting on a porch, which I fully intend to return. One fits inside the other. The gap between them, about an inch and a half, gets packed with wet sand. I used the fine stuff from a children's sandbox 2 houses down. The top gets covered with a wet cloth, a cotton t-shirt, and then you put the whole thing in the shade where the breeze can reach it, and you leave it. This does not freeze water. I want to be honest about that. What it does is drop the temperature inside the inner pot by 10 to 20 degrees below ambient air. On a 90-degree afternoon, you get 70 degrees inside. That doesn't sound revolutionary until you understand that 70 degrees is the difference between food lasting hours and food lasting days. Every 10-degree drop roughly doubles how long something stays safe. The Zephyr pot is not a freezer. It is a spoilage delay system that runs on air and water and the laws of physics. No moving parts, no inputs beyond water every few hours to keep the sand damp. You can build it in 20 minutes and it runs indefinitely. I started thinking of it as a team player rather than a solution. It can't make ice, but if you make ice by other means, it slows the melt. It buys time. In a long situation, time is the real resource. Day 4 was the vacuum experiment, and I need to tell you about it carefully because the principle is sound and the results are real, but the setup requires patience and some tolerance for failure. Water boils at 212 degrees Fahrenheit at sea level. That's because of air pressure pushing down on the liquid surface. You reduce the pressure, you reduce the boiling point. You reduce it enough, water boils at room temperature. And boiling is endothermic. It pulls heat from the surrounding liquid to turn itself into vapor. Pull enough heat and the remaining water freezes. I used a thick-walled glass mason jar, 3/4 full of water, sealed with a lid I drilled a small hole in and fitted with a rubber grommet. Into that grommet, I inserted a tube connected to a hand-operated brake bleeder pump, which is a $20 tool from any auto parts store that I had in a drawer from years ago when I used to work on my own car. The pump creates suction. I pumped it. At first, nothing. Then the water surface started shimmering. Then small bubbles. Then a visible boil at room temperature, which is one of those things that looks wrong enough that you stop and stare. I kept pumping, kept the vacuum up, watched the temperature on a small probe thermometer I'd stuck through the seal. It dropped. 45 degrees, 40, 38, 35, 33, and then at the edges, ice. Not much, maybe a 1/4 inch of ice crystal along the inside glass and a slush layer in the bottom, but genuine physics-created ice with no chemistry, no electricity, no external cold source, just a jar, a pump, and the latent heat of vaporization doing its job. The limitations are real, small batches only, maybe 200 milliliters of usable slush per attempt. The seal has to be tight. One small leak and you lose the vacuum and the process stops. Thin glass will implode under vacuum, which is why the thick-walled mason jar matters and not the thin decorative kind. Test your seal before you rely on it. And once you stop pumping, the pressure equalizes and the ice melts fast, so you need to transfer it immediately to your insulated container or Zephyr pot to extend it. It's a skill, not a switch. The first 2 attempts, I lost the seal and got nothing. 3rd attempt worked. 4th was better. Like most things worth knowing, it gets easier the more times you do it wrong.
The 4th night changed everything. I'd read something years ago about the Persians making ice in the desert. In the actual desert, where it barely rained, where summer days hit 120 degrees, and storing it through summer in pits they'd built for exactly that purpose. I'd filed it away as interesting and never thought about it again, until the 4th night when I found myself sitting outside at midnight because I couldn't sleep, and I looked up at the sky, and I remembered. Every object above absolute zero emits heat as infrared radiation. Your body does it. The ground does it. The water in a tray on your porch does it. That radiation travels upward, and most of it passes straight through the atmosphere and into space, through a specific window in the infrared spectrum where our atmosphere is transparent. Space is 2.7 degrees above absolute zero. It is the coldest thing within reach, and on a clear, calm, dry night, a shallow tray of water, properly insulated from the ground beneath it, will lose heat to space faster than it gains heat from the air around it. The water temperature drops. below ambient, sometimes well below ambient, in the right conditions, below freezing. I took a baking sheet, filled it with half an inch of water, set it on a bed of dry leaves and straw I'd pulled from a pile by the fence, which insulated it from the ground, elevated the whole thing on 2 cinder blocks so it had clear sight line to the open sky and no ground contact. No clouds, low humidity, still air. I went to bed. At 4 a.m. I went back out and I cracked the ice with my knuckle. Air temperature was 41 degrees. The water had frozen. The radiative loss to space had pulled more heat out of that shallow tray than the 41-degree air had put back in. An ancient Persian principle working on a suburban porch in the dark. 2.7 Kelvin of outer space doing the work, and all I'd contributed was a baking sheet and some straw. The conditions have to be right. Clouds stop it completely. They reflect the infrared back down. High humidity weakens it significantly because water vapor in the air does the same. Wind brings warm air to the surface and fights the cooling. This is a clear sky, calm night, low humidity method. In a desert climate, it works reliably. In a humid coastal climate, it's marginal. But when it works for free. All night, every night, the sky cooperates, with no chemistry, no equipment, no inputs at all beyond the setup. Day 5, I dug a pit, 3 feet deep, 2 feet wide, 4 feet long, lined the bottom with dry leaves, packed straw into the walls, collected everything I'd managed to freeze over the previous nights, the vacuum ice, the chemical ice, the sky ice, broke it up, packed it in, covered it with a thick layer of sawdust I'd swept from the floor of an old shed, then a tarp, then a layer of dirt over the tarp. Inside that pit, the temperature measured 34 degrees in late spring, with ambient air at 75. The Persians called structures like this a yakchal. They were building them at scale, 20 meters tall, brick and mortar, engineered to preserve tons of ice through the Persian summer. The principle inside my pit and inside a 2,000-year-old yakchal is identical. Insulate the thermal mass, stop heat from getting in, and let the ice do the rest. A well-built pit like this loses less than 10% of its ice volume per month. What you harvest in winter, you can still use in August. This is not a solution for tonight. It is a solution for the month after next. The difference between surviving a crisis and managing through one is exactly this kind of thinking, not just what works now, but what builds a system that keeps working. So, here's what I know now that I didn't know a week ago. You can freeze water with a cold pack in 45 minutes. You can make ice slush with a bicycle pump and a mason jar. You can use the sky itself as a cold sink if the night is clear and dry. You can keep everything you make frozen for months if you bury it right. And between all those moments, the Zephyr pot keeps things cool with nothing but air and moisture and 2 clay pots you can carry under one arm. None of these are one perfect method. They're a system. You harvest ice on clear nights. You extend it in the pit. You supplement with chemistry when you need it fast. You slow the melt with evaporation in the shade. They work together the way things in nature work together, not because one is enough, because none of them have to be. The insulin made it. That's the part that mattered, and what I learned trying to keep it cold is something I'm not going to forget, not because I studied it, because I needed it. That's the only kind of learning that sticks. Stay sharp, stay alive.